Hello everyone. Today we'll talk about the solution of the problem, find the power of case size subarrays 1. Let's first look at this definition of a power of an array, assuming that the array has this specified length k. We have an array. We want it to be consecutive elements sorted in ascending order, because otherwise the power is -1, and if they are consecutive and sorted, then it's the maximum element. So it means that we have some element I, then we have I plus 1, and so on, up to I plus the length of this array. So the answer is either this last element or this first element plus this number of elements -1. However we want, we just have to look at the last element. This is probably the simplest way, but only if this is indeed consisting of consecutive elements. So that's fine. However, the problem asks us to find the power of all subarrays of size k. In other words, we have a bigger array and we want to get slices of size k. So like this is the first slice, then the next slice drops this element but takes this element, and so on. So we have to answer for every subarray of size k and return it as a list, which means that we should probably find a way to calculate the result for the first subarray, for this prefix, and then to be able to adjust the answer quickly when adding one element and removing the corresponding element from the left. Can you think of a way to do it? As it turns out, it's possible to do it quite easily. That's because what we want essentially is to maintain the length of the longest suffix that we've currently looked at, that's indeed consecutive and sorted in an ascending order. It's easy to add a new element because either this element is consecutive with the previous one, so either it's one more than the previous one, in which case we take the previous longest suffix and it's now longer by 1, or it's not the next consecutive number, in which case the only suffix that we can get consists of only this last number, because here already we have a problem. And now knowing that, we know that we are interested in arrays of size k, which means that if that length is equal to at least k, then this is a correct subarray and its power is of course this last element, as we've talked previously. Otherwise, if that length of the longest suffix does not reach k, is smaller than k, then the answer is -1. This is a linear time solution. We can immediately, for k equal 1, just return the array. It's convenient for the way I've written it, but this is of course the obvious edge case, which maybe you will not have to deal with, depending on how you implement it. And we'll be maintaining the length of the longest suffix and of course the result array. We go through all the elements, comparing the current element to the previous element. It has to be equal to previous element plus 1. If it's not equal, then our length is equal to 1. Otherwise, the length is the same as it was, plus 1. And now, if this is indeed at least so we've reached the kth element, so we can start filling in the result array. This is the check for I. We either append -1 if the count is smaller than k, otherwise the count is equal to at least k, which means that our length of the longest suffix is long enough. The answer is the last element of the current subarray, which is just nums of I. And at the end we just return the result. So it's a standard sliding window problem, but we don't really even explicitly move the left element forward. The only part where the left element even comes in is that the length has to be, so the length of our subarray has to be at least equal to, well, what it needs to be equal to. So these are those two checks. This check for the length of the longest suffix and this check for how many elements we've seen from the beginning of the array.